Hey folks, welcome back to our next lesson in geometry. We've been working with the Cartesian plane and 2 dimensions for a while. Today we're actually going to work in just 1 dimension with a straight line segment. Reason being is we're building up to an idea that we're going to see in Thursday's lesson when we go back to the Cartesian plane. But it's a lot easier to think about it in 1 dimension first, then on Thursday we'll apply it to 2. Let's take a look at what we mean when we talk about proportional line segments. So we're going to take a little break from 2 dimensions and talk about 1 dimension right now. This is going to tie into Thursday's lesson where we go back to 2 dimensions. But we're going to do it first in 1 and then we're going to go back to 2. So take a second, pause the video, and read the problem that's below. Cool. So we're told they're all on the same line segment. Let's draw it out. All right, now let's label it. We know that we have this ratio. Okay, so from f to g is 3. It's 3 times some number x. From g to h is 2, and it's 2 times some number x. And then from h to I, hi guys, is 4, so it's 4 times some number x. Now we're also told that fi is 18. So this entire thing is 18. So we know that 3x plus 2x plus 4x has to equal 18. So 3x plus 2x plus 4x equals 18 because they're representing the same line segment. Well, 3 and 2 is 5 plus 4 is 9. So 9x is equal to 18. And if we just divide both sides, we get that x is equal to 2. Cool. Well, now we can use that. If x is equal to 2, I can just plug 2 in for each one of these. This x, and that x, and that x. Well, 3 times 2, that's 6. 2 times 2, that's 4. 4 times 2, that's 8. Now, careful, we need to figure out what we're trying to find. Luckily, they got to tell us what we're trying to find. Here it's FH. Well, FH is here, this distance. We knew before that it was 3x and 2x. Well, now we know that it's 6 and 4. So that means that FH is just equal to 10. So even though it was in 1 dimension, we still made an equation, we still set it up, we still solved it, and we still drew a diagram. Cool. So that was our first example. We're going to take a look at a second one now. Very exceptionally similar to the first one. Going to go over that same process. Let's take a look. So here's our second example. Pause the video and read it. So a really similar thing to what we had last time. The ratios are different, and we're finding something different. We're finding 1 part instead of 2. Same deal. When in doubt, graph it out. Awesome, so we got that. And now we know the ratio of RS to ST to TU is equal to this. This is first, so that's first. This is 2x. This is second, that's second. This is 6x. That's third, this is 1x. You could also just put 1. We know that RU, ready for math, RU is just equal to 54. So that's the whole thing. Now we're just going to set up an equation and solve. If you want, you can look ahead and try to figure out what we're trying to find. We're trying to find ST. That's just going to be this distance. Cool. So we're going to have 2x plus 6x plus 1x. And we know it has to equal 54. All right. That's 8. That's 9. So we have 9x is equal to 54. Last but not least, we have x is equal to 6. Cool. Let's just plug it in and find. X is 6, so this is 2 times 6, it's 12. This is 6 times 6, it's 36. This is 1 times 6, it's just 6. And we're finding ST. We already did. It's just 36. If you want to check it real quick, add these 3 up. They should equal 54. If they don't, something went wrong. So at this point, you've seen two examples, and you might be thinking to yourself, okay, I know what Gallagher does. He gives us two examples, and the delta math's completely different. Well, that's not happening this time, because those two examples were from delta math. I just clicked show two problems. So, give the delta math a shot. You just need 5 of them right. And if you're having any difficulty, remember the steps we did. We drew a diagram. We labeled the diagram. We set up an equation. We solved the equation, and we just applied that x to our diagram. Give it a shot, and you can get in touch with me at any point. I will respond during office hours. Have a great day, folks. Stay safe.